Okay, so another example here. In this equation, we've got a radionuclei with 6,000 undecayed nuclei when T is 0. So we start off with 6,000. We've got 2,390 undecayed nuclei remaining after a time of 5.2 seconds. So that's the information we've got, and we want to work out the decay constant. So what we're going to need to do here, so working out the decay constant. The first thing we're going to need to do is use this equation. And what I'm looking for is that. Okay. Now, before we start this, it's worth being aware that when you log to the base e of minus lambda t will just give you minus lambda t. Because if you think about it, this here, okay, e to the minus lambda t is equal to some value, which is actually e to the minus lambda t. So when we do this here, we're saying, what value do I need to raise e to? What value do I need to raise e to get this answer? Obviously, when you evaluate that function there, you're going to get a number, aren't you? But what value do I need to raise e to get this answer? Well, hopefully you can see I need to raise it to minus lambda t. So really important to be aware that when you natural log or log to the base e, when you natural log an exponential function, okay, raised to a certain power, the answer is just the power. Okay. So what we can do here is we're going to rearrange this equation. I'd rather rearrange before putting the numbers in. So let's do that. So we're going to do, first of all, we're going to divide through by n0. Okay, divide both sides by n0. So we're going to get n over n0 equals e to the minus lambda t. Then what we're going to do is we're going to multiply both sides by natural log. Okay, so ln n over n0 equals, when you natural log an exponential function, it just gives you the power. So we get that. ln of 2390 over 6,000 is going to be equal to minus lambda multiplied by 5.2. So if you put that into your calculator, you're going to get natural log of 2390 over 6,000, and that's going to give you minus 0.920 is equal to minus lambda times 5.2. So therefore you can just multiply both sides by minus 1, and that will make, so that will obviously give you 0.920 equals 5.2 lambda, and therefore lambda is equal to 0.920 over 5.2, and that's going to give you 0.77. Okay, so 0.177, sorry, I should say, what am I talking about? 0.177 per second. All right, so that's the first part of the question done. Now the next part of this question says, how many undecayed nuclei will there be after 3.6 seconds? So let's just section that off. So after B, how many undecayed nuclei will there be after 3.6 seconds? So we're going to use this equation now. N equals n0 e to the minus lambda t, because we now know lambda. So n is going to be equal to 6,000 multiplied by e to the minus 0.177 multiplied by 3.6. Okay. That's going to give you 3172.63. Okay, 3172.63. Now part C says, what's the activity after 3.6 seconds? Well, again, we can just use A is equal to lambda n. So A is equal to 0.177 multiplied by 561.63. That's going to give us 561.55. And that's becquerels. Okay. So there you go. That's that question done as well.